Hello and welcome to another class with Professor Choi. Today I'm here to talk about continuous probability distributions and more specifically about normal probability distributions and how to find a probability on that particular distribution. Okay? So imagine that you conducted a study of population income and found that the household income in Choitropolis, fake city, followed a normal distribution with a mean of 35,000 and standard deviation of 10,000. Alright? And somebody comes to you and asks you a question. Now, what could be one of those questions that they could ask you? So let's say that they ask you, what is the probability that a citizen of Choitropolis makes more than 50,000. Okay? So again, we have conducted a population study and we found that the household income in Choitropolis follows a normal distribution with a mean of 35,000 and a standard deviation of 10,000. And the question is, what is the probability that a citizen in Choitropolis makes more than 50,000? Okay? That's the question. So, let's go at it. Every time you're finding one of these probabilities, it is very useful to draw the distribution, and that's just to visualize what you're doing. So over here, remember that population mean is mu, we use that letter for that, and 35,000. And we know that population standard deviation, we use sigma, and that number is 10,000. So if I were to put it over here in my normal distribution, my mu is equal to 35,000, and my sigma is equal to 10,000. Alright, now, in order to be able to calculate probabilities of any normal distribution, usually you have to turn it into a standard normal distribution. And you turn it into a standard normal distribution by following this formula. You got to do z equals x minus mu, that was terrible mu, divided by sigma. So z equals x minus mu divided by sigma. Okay, so I'm going to take this 50,000, which is here, to the right of 35,000, and I got to turn it into a z value. Now I know that if I turn this into c values, I'm going to get mu 0 sigma of 1. So in order to turn my 50,000 into a z, I got to follow this formula here. So z is equal to 50,000 minus mu, which is 35,000, divided by sigma, which is 10,000. Okay, so we got 15,000 divided by 10,000. And the answer to that is 1.5. Okay, now in order to find the probability of that, so what is the probability that a citizen in Choitropolis makes more than 50,000? You got to get one of these tables. Now, as I may have mentioned before in other one of my videos, these tables are available everywhere on the internet, so you can find them. They're called a normal probability table. Normal areas under the normal curve, or they're called z tables because we're turning it into a z value. Okay, called z table. Now, the particular table that I'm using, if you're in one of my classes, I provide one of these, so you should have it. Okay, you need to look for it on the LMS that I use, so it should be in there. Now, if you don't have it, find one of these tables online because they give you the probability under the normal curve. Now, in this particular case, this table always gives you the probability between the center and whatever number you're looking for in here. So that's what you're always getting here. You get the probability between the center and whatever number you're looking for, right or left. Okay, so if I take this 1.5 to find the probability for it, I gotta go into my table, and then on this section I gotta look for 1.5, and because this is 1.5, 0, then I'm just gonna slide to the right to 0, and then there's a 1 and a 2 and a 3. But this is 1.50, so I'm just going to slide to 1.5, and then right next to it is 1.50. So I'm going to go to 1.5, and then slide to the right, and that is 0, 1.50. So the answer is 0.4332. 0.4332. So on the probability between the center and that number is 0.4332. Now, the question that they're asking us is not that number. The question that they're asking us is, what is the probability that a citizen makes more than 50,000? So they're asking us for this area, more than 50,000, not less than 50,000, not between 35 and 50,000. Okay? So they're asking us for more than 50,000. Therefore, the answer is, if you remember, to the right of the normal distribution, you find half of the probabilities, and to the left of the normal distribution, you find the other half. So the answer to our question is to basically do that 0.5 and subtract the probability between the center and this number. So we can get this number here. So we take the large number, subtract the small number to get this number here. So the answer to my question is 0.0668. And 0.0668 or 6.68% is the probability that a citizen in Chotropoly makes more than 50,000, according to this data that we found. And again, the data is fake, but that's the data. All right. Let's do another question. Same data. Follow me, or you need some coffee? Go get some coffee. Stop the video right now. Go get some coffee. Come on. All right. Let's do this. So, different question. What is the probability that a citizen makes between, let's call it 25,000 and 35,000. Okay? So what's the probability that a citizen makes between 25,000 and 35,000? All right, so we got our graph here. Center of the graph, we got this 35,000. And we got our sigma equal to 10,000. All right, question is asking us, what's the probability that somebody makes between 25 and 35? So we got to go left 2, and that's what they're asking us. Between 35 and 25,000. Step number 1 is to standardize it. So we're going to go, and mu is going to become 0, sigma is going to become 1 when we use this to standardize it into z. Then we got to standardize that 25,000. So z equals 25,000 minus 35,000 divided by 10,000. And again, I'm using this formula here to find my z. So I'm going to do x, which is 25,000, minus 35,000, which is my mu, divide by sigma. Sigma is 10,000. Okay? So this is going to give me -1. Alright? So my value here is -1. Okay, now with my table, I can find the probability of -1. Now remember, that negative just means that it's to the left of the center. In my particular table, there are no negative numbers. But you don't really need them, because remember, half the curve to the right is similar to half the curve to the left when you have a normal distribution. So if I give you the probabilities of the numbers to the right, they're exactly the same as the numbers to the left. So on the table, when you get a negative number for z, that's okay. You just look for the positive of that. Okay? And all we're looking for here is the number 1. So we go down the table, look for 1, and we go look for 1.00. And the answer is 0.3413. So the probability between the center and that number is 0.3413. So in this case, you're asking us what is the probability that a citizen makes between 25,000 and 35,000. Because this particular table always gives you the probability between the center and the number, then we already have our answer. So our answer is equal to 0.3413, or 34%. Alright, now, if you remember on one of my other videos where I was explaining that using the empirical curve, the empirical rule, you can find some of these answers faster, then you would have already known the answer to that. Because this is one standard deviation to the left of the center. So we can split this curve, and when we do mu plus or minus 1 sigma, we're going to find 68% of the data between those two, and half of 68 is 34%, which is the portion that they're asking us right now. So you would have gotten 34% or 0.34 if you would have remembered the empirical rule. You would have basically known the answer right away, because this number is exactly one standard deviation away to the left of the center of the data. Alright, let's do one last one. You get my water. Ah, here we go. Alright, we already had all the coffee I was going to have, so water for now. Okay, let's do one last one. So same data, different question. What is the probability that a student, oh, not a student, we got citizens. Alright, that a citizen makes less than let's call it 40,000. What is the probability that a citizen makes less than 40,000? Alright, always start with the curve, just works better. So here we go. I know that the center of my curve, my mean, my median, and my mode is at 35. And I know that the standard deviation is 10,000. Alright, they're asking us for what's the probability that a citizen makes less than 40,000. 40,000 is to the right of 35,000. 40,000 is over here somewhere. That's 40,000. Okay? We're going to use this and standardize it. So mu becomes 0, sigma becomes 1, and I got to find the z-value for that 40,000. The z-value for that 40,000. So, z is equal to 40,000 minus mu 35,000 divided by sigma 10,000. Okay, so this is going to give us 0.5. Okay, now that 0.5 is the z-value of 40,000 using these numbers here. What the question is asking us is, what is the probability that a citizen makes less than 40,000? So we're going to be at 40,000, and anything less than that, that's what they're asking us on the question. Okay? So, 0.5, it goes here. Alright, now, every time I'm looking for a probability on my table, I'm looking at the probability between the center and whatever number I give it. So if I give it 0.5, I'm getting the probability between the center and 0.5. Alright? So to find the probability between the center and 0.5, I go to 0.50. And I find it to be 0.195. So it is 0.195. Alright, now the question is asking us, what is the probability that somebody makes less than 40,000? So it is not just that portion, but I also need to find all of that stuff on the other side of the curve. But we remember that when you have a normal distribution and you're splitting exactly in half, then half to the right is 0.5, the half to the left is 0.5, so that I know that between this and the entire left is 0.5. Therefore, the answer to my question is equal to 0.5 plus 0.195. That's my answer. So this is equal to 0.695. There you go. So the probability that a citizen in Choitropolis makes less than 40,000 with this information is 69.5% or 0.695. Alright, I hope you enjoyed the lesson today with Professor Choi, and I hope you join me later at a different lesson. Remember to subscribe to the channel if you like this conversation. Have a good one.